Okay. See, adjoint of a matrix is a matrix. Okay. Then what will be there in the adjoint of the matrix? Means, you remember we got this matrix A as what it is: A1, B1, C1, A2, B2, C2, A3, B3, C3, right? This is a matrix A3, B3, C3. So, okay, for this we'll write cofactor matrix. Remember what is the cofactor matrix? This is A1, B1, C1, A2, B2, C2, A3, B3, C3. That means each one is a cofactor of that corresponding element. Okay. So, if you take transpose of this matrix, that is called as adjoint of a matrix. Okay. If you take transpose of a matrix, that is called adjoint of a matrix. Simple. Okay. For the cofactor matrix, you take transpose. That is adjoint of a matrix. Okay. Now we'll take one example and we'll see. Like the adjoint of a 2 by 2 matrix. Adjoint of a 2 by 2 matrix. See, you take one 2 by 2 matrix, that is A, B, C, D. This is a 2 by 2 matrix. We call it like A. Okay. And the adjoint of A is what? The transpose of a cofactor matrix. Okay. Cofactor means what? We'll leave this row and column and the remaining thing we'll take for the determinant. So, determinant of D, that is D only. Okay. So, D. Okay. That is the cofactor. Positive one. Okay. And next one will be negative. Remember, this is positive, negative, negative, positive. The cofactor side. Okay. So, this is the cofactor of this first element. Now, what is the cofactor of the second element? B. This row and this column. That is C. But with a negative. Because cofactor sign is negative. Okay. And for the next element, for the element C, which one is the cofactor? You leave this row and this column. And this is our cofactor. So, for this also, this one, I mean, like what? Cofactor sign is negative and this is the minor. Okay. And the next one, for D, which is A. For this, you should take the transpose. Okay. Taking the transpose means what? Simply changing rows into columns, columns into row. So, we'll get D minus C and minus B A. Alright. So, this is the adjoint of a 2 by 2 matrix. This might seem confusing. Is it? So, instead of doing like this, I'll give you one small idea. What is that idea? That is, we remember that taking determinant of a 2 by 2 matrices, right? So, simply whatever the matrix is given of 2 by 2, the adjoint of the matrix A is simply, first we will multiply in this direction, right? While taking determinant. So, in that direction, we should be doing the place change. Just change their places. That's all. So, in this direction we multiply. So, those two elements will change their places. So, here D, here A. Are you listening here? I am telling you a shortcut. Okay. Or if that method is okay, you can continue with that. No problem. See, you want me to change the shortcut or shall you go to the next one? Okay. Can you see the board? Nice. See, in this direction we should change the place. And next one, the other direction will right now, will multiply. No, in that direction, we should be changing the sign. That's all. So this is place change and this is sign change. B means minus B, C means minus C. That's all. We don't need to confuse with the cofactor, minor, transpose. No need. Simply place change, sign change. For example, take this matrix 2 minus 3 4 6. The matrix A is 2 minus 3 4 6. Now the adjoint of A directly you can write. How we can write? Here we can change the places. So here 6 2 and the other direction we will change the sign. So here minus 3 means positive 3 plus 4 means minus 4. Alright. That is it. Directly adjoint. Any doubts on this? Only for 2 by 2 this method. Concept wise it is same. You should write the cofactor matrix, in that we will put the transpose. Okay. Here also I applied the same. But for a shortcut I am saying that simply place change, sign change. Easy. Quickly you can do. Instead of focusing on each element, simply you can change the place and change the sign. We'll move on. That's all. Okay. Now, shall we go to the next one? The adjoint of a 3 by 3 matrix. Clear is? Adjoint of a 3 by 3 matrix. Okay. The concept we already discussed. We'll go with the example. Okay. So we are going to find the adjoint of this matrix. That is 1 0 2 1 0 2 2 1 0 3 2 1. For this we should find the adjoint one. Okay. So it is very clear and evident we should write the cofactor matrix. Okay. Here also by traditional method we will do once and then I will tell you one shortcut. Okay. Both are important. Okay. Now this matrix, let me call it as A. Now adjoint of A means the cofactor matrix. Cofactor matrix means for the first element what is the cofactor? That is 1 0 2 1 with the positive sign. That is the cofactor, right? And for the second element, leaving this row and this column, we'll put 2 0 3 1 with the negative sign. Okay. And for this element, leaving that row and that column, this 2 1 3 2. You understood what I am saying? The cofactor exactly I am writing as a matrix. Okay. Like that for this one, you say what it is for that element A 2 1. What is the cofactor? With a negative sign. Yes, sir. It's not 2 into. Simply say the numbers 0 2 2 1, right? And this is positive sign, leaving that row on the column, we'll get 1 2 3 1. Okay. And this one with a negative sign again for this element 1 0 3 2, and for this element 1 again with the positive sign, that is 0 2 1 0. Okay. See, leaving this one, this column for this element. Alright, and then with the negative sign, and this is what for this element, that 1 2 2 0, and for this element it is 1 0 2 1. Okay. This is the cofactor matrix that I written. No, A, B, C, sorry, capital A1, capital B1, capital C1. That matrix is this one. We should take transpose of this matrix, that you just understand. Okay. And now find the determinants, man. The adjoint of A is, this determinant is what? 1 minus 0. So that is 1 only. And this is 2 minus 2. Because 2 minus 0 with a negative. This is 4 minus 3 plus 1. Now this one 0 minus 4 with a negative outside, it is plus 4, and 1 minus 6 which is minus 5, and that is 2, sorry, minus 2, and this one 0 minus 2, and that one 0 minus 4 with a negative, it is plus 4, and that is 1 minus 0, it is 1 only. Don't forget to put the transpose. Okay, then we can write the transpose of this matrix. What is the transpose? This is 1 4 minus 2. First column I transpose into a row, and this is minus 2 minus 5 4, and this is 1 minus 2 1. This is the adjoint of a matrix, man. Okay, any doubts on this? No. Okay, now let's see one more definition. Let me check the answer. This is 1 4 minus 2 minus 2 5 4 minus 2 minus 5 4 1 minus 2 1. Yes, perfect. Let's see one more definition, man. Inverse of a matrix. What is inverse of a matrix? See, a matrix multiplied with another matrix, and that matrix multiplied with this one will get identity matrix. Okay, like in numbers and all, how we will say the inverse? Remember, suppose 2 is there, by adding it to what we will get the identity element 0 with respect to addition. Like minus 2 is the inverse of plus 2, right? Likewise, for the number 2 is there, with respect to multiplication, what is the element we will get? By multiplying with what we will get identity element? 2 is there, with respect to multiplication, what could be multiplied to get the multiplicative identity? 1 by 2. Yes, that is 1 by 2 is the inverse of this, and 2 is the inverse of this 1 by 2. Okay, so the same way in matrix also, there will be one matrix. While multiplying, whether we pre-multiply or post-multiply, either way we multiply, we'll get identity matrix. Okay, we call such matrix as inverse of a matrix. Okay, sorry, it is not AB is equal to BA, my fault. Like when we multiply these two matrix, we'll get identity matrix. So we say this B is the inverse of A. That means A inverse is equal to I. Okay, and A is the inverse of B. Each of them is inverse of each other. They are inverse of each other. Okay, now how to find such matrix? The idea is same. By multiplying into what matrix we get identity matrix. That is the thing. Okay, so how to identify that matrix? Very easy. For that, one small formula is there. That formula is, I will take the same question. Like instead of finding the adjoint, we will be finding inverse. Find inverse of this matrix A, let us call it. Okay, so the formula for the inverse is, for a matrix A, the A inverse is 1 by determinant of A into adjoint of A. That is it. That is the formula. Provided that here this determinant of A must not be equal to 0. We have seen previously with the determinant of A become 0. We have seen the separate kind of matrices. What is that kind of matrix? If determinant of A is equal to 0, singular matrix. So, if a matrix is singular, inverse does not exist. If it is not singular, inverse exists. Okay. So here, whenever we start to find the inverse, first we should check the determinant, whether the determinant becomes 0 or not. Suppose the determinant becomes 0, we'll close it with the note that inverse does not exist. Suppose the inverse exists, we'll find it out. That's all. Okay, so like determinant of, yes, that is a scalar, that is a number. Okay, determinant of A we should find. It is what? 1 into the minor, that is 1 minus 0 minus 0 into whatever it is 0 only. Better we'll write 0 into 2 minus 0 and then plus 2 into this is what? 2 minus 3, which is minus 1. Oh, sorry. 4 minus 3, which is 1. Okay, so we'll get 1 plus 2. So 3 is the determinant value, which is not equal to 0. So it is not singular. It is a non-singular matrix. And the inverse exists, which implies the inverse exists. How to find the inverse? For this matrix, we already find adjoint, right, in the previous question. So simple. So adjoint of A is here. So inverse is what? 1 by determinant of A into adjoint of A. So that is our inverse. That 1 by 3 also we can multiply inside. Okay. When we multiply that inside, what it will become? It will become 1 by 3, 4 by 3, minus 2 by 3, which is minus 2 by 3, minus 5 by 3, 4 by 3 and 1 by 3. That is it. That is how inverse works. Okay. Any doubts on this? So adjoint, you don't have any doubts? Yes. Shortcut is there, that I will say. Okay. I thought of saying this, that's why I said. See, while finding the adjoint, it's a big process, right? Like such a big matrix, you should write, calculate the determinant, take the transpose, everything. But there is one shortcut. We'll see the shortcut for the same matrix. Okay, shall I erase everything? Okay, we'll keep this for the answer. Okay, now we are going to find the shortcut. Adjoint only, with the shortcut we are going to find. Okay, so the shortcut is quite easy. That simply you can write adjoint of A is equal to, see, there are 3 rows. We should be starting with the middle element, second row, second element. Okay, so write that accordingly, 1 and then the next one 0 and go with the cyclic order, 2 and again come back here, 1. I wrote the elements in this order. Okay, any doubts on this? I started with the middle row, middle element. So from right to left one cycle I came. The same way next row element should be written. Next row element is what? Like middle element, which is 2, then go here 1, then go for a cycle 3, again finish it with the 2. Okay, the same for the first row also. So 0, 2, 1, 0. Okay, now again you should start with the, you should finish with the middle row. So that is 1, 0, 2, 1. It's either copying the first row or, see, middle row we started, again middle row we are finishing. That is it. That one's complete cycle. You understood, right? This one, or shall I explain this once again, how I wrote all this? Okay. And put one matrix. Don't forget to put transpose. Don't ever forget to put the transpose. Okay. For this also you should take the transpose. Okay. And simply for 4 numbers you put the cross. You don't need to worry about the cofactor sign, positive, negative and all. You don't need to worry. Okay. Totally how many cross signs I kept? 9 cross signs. Each gives you each element of a matrix. Okay. So the adjoint is what? Here 1 minus 0. 1 only. And this is 0 minus 2. Minus 2. Next cross mark. 4 minus 3. 1. Okay, and here next cross mark 4 minus 0, 4. Are you getting it? How I am writing all this? Can I explain this once again? You got it right? Okay. Then this is 1 minus 6. Then we get minus 5. Then 0 minus 2. Minus 2. And again 0 minus 2. We get minus 2. Okay. And this one 4 minus 0 plus 4. And again 1 minus 0 plus 1. Apply the transpose. When you apply the transpose, 1, 4 minus 2 is the first column. So I mean first row, right? See 1, 4 minus 2. 1, 4 minus 2. First row. Second row, the second column I am writing the second row. Minus 2 minus 5, 4. Minus 2 minus 5, 4. Third row, third column I am writing is the third row. 1 minus 2, 1. 1 minus 2, 1. We get the same answer, right? Now which is easy? That is far easy, right? So it is not anyway related to the determinant, man. For determinant, this is separate procedure. Along with the cofactor, we should multiply the numbers also. It's a different procedure, right? So don't get confused. Now whether this one is easy or that one is easy. Both are difficult only, but this is taking somewhat less time. So while writing descriptive exam, don't go for this method. Better go with the original method because they will not award marks. But while writing for objective exam, this method could work. This method could save some time. Okay. Maximum will be writing objective exams only, right? No. Okay. Then just go on with this method. So that is about this matrix, I mean adjoint of a matrix and the inverse of a matrix. Okay, now we'll see some properties of this one. Shall I erase this? Okay. Now, properties of adjoint. The definition all we know. If A is a 3 by 3 matrix, then and K is any number, A is a 3 by 3 matrix and K is any number, then the adjoint of K into A equal to K square into adjoint of E. Okay. The same property we have seen previously with the determinant. Remember? Properties of determinant. Can you recall what it is? Adjoint of Ka is what? So not adjoint, sorry. Determinant of K into A is what? K power n into determinant of A. Suppose it is 3 by 3 matrix means here K cube will come. Okay. Both are same like only, but here 1 degree will be less. Don't get confused with those two properties. Okay. And the next one. In general, the same property in general. If A is n by n, A is of order n by n, then the adjoint of Ka will be equal to K power n minus 1 into adjoint of E. Okay. And next, the determinant of adjoint of A. This is an important property. Determinant of adjoint of A. That will be determinant of A power n minus 1. Okay. And adjoint of A. You take adjoint for an adjoint, then it will be equal to determinant of A power n by 2 into the matrix A. Okay. And determinant of adjoint of A, which is determinant of A power n minus 1 square. Okay. This might seem confusing, but let me explain. See, first we multiply a number with the matrix and we take the adjoint. Then it will be equal to original matrix adjoint into the k square, like degree 1 less than the constant. Okay. And this one in general format I written, like 1 degree will be less than the order. We multiplied with the original adjoint. That is the property. Okay. And determinant of adjoint of A is what? We took one matrix, right? Adjoint. For that, if we take determinant, means that will be equal to determinant of A power n minus 1. Okay. Simply, if we take determinant of A is somewhat 4 coming, means it is of 3 by 3 matrix. For example, I am saying, okay, then the determinant of adjoint of A will be the same 4 but the power 3 minus 1, which is 4 square. It will be 16 will be the determinant. Okay. And the same way, we took one adjoint matrix, right? For that, if we take adjoint again, that we wrote for that again we are writing adjoint, then it will be equal to the original determinant power n minus 2 into adjoint of the original matrix. Oh, sorry, not adjoint, into the original matrix. That's all. Okay. You remember A transpose, whole transpose, we wrote the matrix A itself. The same way, adjoint of A, if we take adjoint of A also, we will get the same matrix A, but it will be multiplied with the determinant of A power n minus 2. Okay. What about now? Alright. The network is fluctuating, man. Okay. See, let me explain once again. See, we wrote A transpose, whole transpose is A. The same way, adjoint of the matrix is A only, but it will be multiplied with the determinant power n minus 2. Okay. And if you take determinant of this, means it will be determinant of A power n minus 1 square. Okay. That is it. Any doubts on this? Okay. Okay. Just a moment. Let me fix it. Shall I erase everything? Okay. Now inverse of a matrix. I gave you the definition, right? Did I give you the definition or not? Okay. The definition is correct only, but I got confused. See, it is AB is equal to BA is equal to identity matrix. Okay. Then we say this B is inverse of A and A is inverse of B. Okay. To find the such inverse only, we get the formula that 1 by determinant of A into adjoint of A. Okay. Alright. And the properties of the inverse. See, first of all, we say that matrix B is the inverse of A. That I told you already. And the second one, like then A inverse is equal to A inverse A is equal to I. The same thing. We have seen this somewhere. Remember? Some orthogonal matrix. What it is? A into A transpose into A is equal to A. Same like, but here inverse also will satisfy this matrix. Okay. And then for the products AB and BA to be both defined and equal, it is necessary that A and B are the square matrices of same order. Thus, non-square matrices cannot possess inverses. Okay. See, we said AB is equal to BA, right? So here A and B must have same order. Is one point. Also, for non-square matrix, not for non-square matrix does not possess any inverse. We cannot find inverse for the non-square matrix. Okay. And every square matrix need not to have an inverse. It possesses an inverse, then A is said to be invertible. So, we said that for square matrix only inverse exists. But it happens that for some square matrix also inverse does not exist. Why? We discussed this point. Why inverse will not exist? They become non-singular. They become singular. Okay. So, if it possesses, if a square matrix A need not have inverse, possess an inverse, then we say A is invertible. That is an invertible matrix. Okay. Simply, if determinant of A is not equal to 0, directly you can say a square matrix with determinant of A not equal to 0, this is an invertible matrix. Okay. And the inverse of identity matrix is itself. Okay. And if A is an invertible matrix, if A is invertible, then A inverse whole inverse is that matrix itself. Previously, we have seen same kind of property. One thing, remember, A transpose whole transpose is equal to A. In that order, A inverse whole inverse is A. Okay. Shall I erase this column? Okay. What happens if you take determinant of inverse of a matrix? Previously, we have seen determinant of adjoint of a matrix. Recall what is determinant of adjoint of a matrix? Determinant of A power n minus 1. Okay. Now, if you take inverse of this, determinant of this inverse matrix means it is simply 1 by determinant of A. That's all. Okay. and it followed by several theorems. The theorem 3.3. Every invertible matrix possesses one and only one inverse. Okay, one and only one inverse means what? Inverse is unique. Only one matrix we say it is a inverse of a matrix. So that means what will be multiplied with 2 will get 1. 1 by 2. Any other thing will be? No, right? That is the thing. So inverse is unique. Okay. That is what the theorem 3.3 says. And then 3.4. If A and B are invertible matrix, then AB whole inverse. That AB whole inverse is equal to B inverse into A inverse. Okay. Same like we have seen one property before. What it is? AB whole transpose. B transpose A transpose. This is B power T A power T. Okay. And the same way, they are saying this theorem, we mark it as a notes. Okay. A inverse transpose is equal to A transpose inverse. Again, we have seen some other property like this. Determinant of A transpose is equal to determinant of A. No, not like that. Not right. Some other thing. I can't recall what it is. This like we have seen on property. Yes. A power n t is equal to A power t whole power n. That one. Yes. And the theorem 3.6. It is simply the formula only. If A is a non-singular matrix, then A is invertible and A inverse is equal to adjoint of A is equal to, see, A inverse is equal to adjoint of A by determinant of A. New formula, right? Is it new form? Think well and say no. That is direct formula, man. We know this formula already. Remember, 1 by determinant of A into adjoint of A. Same formula but with a different picture. Okay. Okay. And that followed by several properties again. It's full of properties only now. So let us solve this. What happened? Network is fluctuating. Right part first. A inverse whole determinant. Yes, I'll explain it. Yes. See, that determinant of A inverse is, what is the formula for A inverse, man? 1 by determinant of A into adjoint of A. We are saying it is a determinant of order n by n. Okay. Then if we take determinant of that matrix means With determinant of 1 by determinant of A into adjoint of A. Okay. You remember, this is a number K, right? Is it? Let us say the number K is 1 by determinant of A. Okay. Then this will become K into adjoint of A. Okay. And we have one formula, one property. What is that property? Is what? Determinant of K into one matrix. Then the constant can be kept out as what? Not n minus and all. K power n into determinant of A. Okay. The same way here also we can write what? This determinant of A inverse can be written like K power n into determinant of adjoint of A. Right? Any doubts on this, or shall I explain this once again? Okay. Shall I erase this side? Okay. Now K power n is what? That is 1 by determinant of A power n, right? No, 1 by determinant of A whole power n. And determinant of adjoint of A, what is the formula? Now only we saw. Determinant of A power n minus 1. Okay. Is it or not? Now only we saw one property, right? So this is 1 by determinant of A whole power n, and this is determinant of A power n minus 1. Then what it is? So 1 by determinant of A power n, this one I am taking into the denominator. When I take this into the denominator, it will become what? Like determinant of A power 1 minus n, like it will become like negative of n minus 1, right? Then these two powers can be added. 1 by determinant of A power n plus 1 minus 1. So plus n minus n cancel, we will get 1 by. Okay. Any doubts on this? Simple. I just applied the taken the definition. For the definition, I applied the determinant. While applying that, I kept the determinant property also. So we got this answer. Okay. Any doubts on this? Okay. Shall I erase? Okay. Okay, we are about to see some more theorems and some more properties. Okay, see, and one more property is like it is a note or remark or property. The matrix A into its adjoint. The matrix A into its adjoint. Are you there? And adjoint of a matrix into that particular matrix, it is equal to determinant of A into I. Okay. This is one property. And the adjoint of A whole inverse. Adjoint of A inverse is nothing but 1 by determinant of A into A. 1 by determinant of A into A. And that is equal to adjoint of A inverse. Okay. And adjoint of the matrix I. I means what matrix? Identity matrix. This I again. Also adjoint of 0 matrix. 0 only. And the inverse of the matrix 0 0 1 0 1 0 1 0 0 is itself. You might think this is an identity matrix, but it is not the identity matrix. When you take a closer look, it is not identity matrix. Okay. So you may think this is an identity matrix, but it is not identity matrix. Like in identity matrix, row and column were interchanged. Okay. Same type, A and B are non-single matrix of same type. Then adjoint of AB is equal to, you guess what will come? We have learned about transpose. AB transpose we written. What we got? B transpose, A transpose, right? Okay, like AB whole inverse, we learnt about inverse, and AB whole inverse, what we got? B inverse, A inverse. And guess what? Adjoint of AB. It is not ADJ of B. Adjoint of B into adjoint of A. Okay. Okay, man, that is it. And we see that exercise, still one more topic to be completed, like characteristic equation of a matrix, and several questions of one more types should be completed. Now look into the exercise 3.5. The first question would be easy, right? Can you able to do it? The first question, simply find the adjoint and inverse of the following matrices. In some of the matrices, it will be coming like determinant is equal to 0. For that matrix and all, what we can do? Inverse does not exist, like we will finish. Okay. And the second question, that is also easy. That equation type and the characteristic equation, those things alone we should continue. That will continue in the next session. Okay. So far what we have seen, do you have any doubts? Like adjoint of a matrix and inverse of a matrix? No. But it comes with plenty of, it's not formulas, they are theorems. They are results. Like all of them are one way or around, they are similar. We cannot memorize all those things, but we can compare and recall all those things. Okay. Like we calculated with what? We compared with this previously existing properties, and we can recall those things. Okay. While seeing this, something else should be remembered. Okay. That is the thing. If you do like this video, please do like, share, comment, and if you have any doubts on this, put it on the comments. Let me see and I'll reply to it. Okay. Thank you for watching.